Good morning, good afternoon, buenos dias, good night, wherever you are. This is the southern of Germany. My name is Dietmar. This is Andres & Hauser, temperature and system product. And there we have Ben.
Hi there. Warm welcome also from my side. My name is Ben. I'm responsible for training here at Andres & Hauser Temperature and System Product. And I will, as you most probably already saw, keep track of everything that's running in the background. We'll support Dietmar, at best. And most important for you, if you are not completely familiar with the tooling that we use, go to webinar. The major part that you should take care of is ask your questions whenever you have them. So there's a questions box. I will try to answer them right away. And in the end of our session, we will have a question and answer session, most probably after the 45 minutes that we scheduled so far. If this person talks about hygienic processes, then I guess we will take every minute there is, and it is rather precious. So therefore, I will speed up a bit. It'll all be recorded. You will get the recording together with a handout at the latest 2 weeks after our session, most probably way earlier, depends on the workload. And last but not least, we'll try to keep that session a bit interactive to entertain you also a bit. So every now and then, when you see me on screen, it is time for you to do something. So we will have a couple of polls. But that being said, I guess that should be all from my side for now, because he's the one, the expert, our brightest nerd for hygienic temperature measurement in Nesselwang. So enjoy.
I need something to throw at him, but he's far away, so he's safe there. He says everything is only technology here.
And it is the term nerd in the best way I could ever mean it. Really, I love working with him, and you hopefully will too, because
All right, so let's start. So interactive, if you see Ben, you have to do something. If I see Ben, I know I have to do something. He will interrupt me if necessary for a question. So let's hurry up. So we like to show you some new ideas about the calibration of temperature sensors today. Like it's done today, like it's probably done at your site. What is our suggestion for changes and productivity gains? All right. So when you need to do it, I have prepared 2 typical applications, both coming from hygienic industry, but there are a lot of other possibilities or needs where you need to do a calibration. One quite popular one is milk production. If you have the raw milk, you have to heat it up to kill the bacteria in it, so it lasts in the refrigerator time longer. And so it is very important to reach a certain temperature to kill the bacteria, but you cannot exceed this temperature, because if you heat the milk too much, you will taste that it was too hot. Huh? And so the temperature measuring point in the milk processes need to be calibrated quite regularly. And in this example, a typical milk heater, it's heated up for a while, for some minutes or hours. The milk will continuously process, and sometimes it shuts down because you need to clean it. So this is one of the typical processes in the milk industry, in the food and beverage industry. One example of many in the life science industry is if you have medical products for surgeries, but also some of medicine, they need to be sterilized at the end. And you are using a medical autoclave like this. And so you put in your goods, and the goods will be heated using pressurized steam to 120 degrees Celsius or more. And they have to be there for a couple of time. And after that, for sure, before you open the door, the process cools down. So to monitor this sterilization temperature, you need a thermometer, and this thermometer has to be calibrated really regularly and accurately. And so this is another CCP, critical control point in process, in a hygienic process, and you will find plenty of these CCP points where it is needed to have a calibration. So the typical calibration process is working like this. You have a reference, and the expert can see it on this blue tag. This seems to be a very special one. You have your device under test, and you need a kind of heat source to heat it up to the temperature where you want to have the calibration. And I think we have a first question for you. Yeah. How? No, it comes later. Sorry, Ben. He was standing up, so I thought I have to do something. All right. So the typical calibration process can be seen also in this short animation. So the comparison change, the traceability of the calibration is, yeah, your device on the test must be calibrated using some test equipment. Maybe it be on site by your service team, by maybe you, by maybe an external company. The test equipment itself needs to be calibrated too. And for this, the next step is a national certified laboratory, like we operate here in our site in South Germany, accredited by the state. And the state itself operates a national institute, and all the national institutes work together. And so, coming from a fixed point, the international calibration standard, this trace of accuracy and uncertainty goes to the measuring device itself. So, the typical way to perform a calibration like this is for a process temperature measurement. It used in automation processes, electrical thermometer wired to the control system. The typical way to do this is, you have to dismount it from your plant. You have to disconnect the cables by opening the head, opening all the terminals and screws. You place it to the calibration, the block calibrator or the calibration bath, or you carry it to the lab. There it needs to be connected again. You perform your calibration using the reference and so on. And at the end, you have to do it the other way around, because connect it in the plant again and so on. So customer ask us, this is a lot of work. We don't like it. What? Please, dear Andres and Hauser company, what can you do for us? Because in average, it takes us 30 minutes for every instrument of production loss to perform a calibration. And so if you think how often you calibrate, and now we're coming to this question, and how many instruments you have in your plant, how many critical control points. It depends. A small dairy maybe have 20 or 30. A big LSI company might have 1,600. So, and then it's really important how often you do a calibration. I've visited a lot of different companies, and so I'm quite curious about your answer.
So, and now you saw me on screen, so straight directly into the poll for you out there. So you should be able to click now in a vote of 4 possibilities: more than twice a year, every 6 months, every 12 months, or less than once a year. How often do you calibrate your critical measuring points? Let us know, on the one hand, your market feedback, and secondly, whether you are still here. 9 minutes after we started, you should more or less all be here now. So also the ones who arrived late, welcome to our online seminar on calibration, a new approach. Of course, focusing on temperature measurement.
So
we will leave the poll.
Do we have answers, Ben?
we have some answers, but we do not have that many answers yet. So I'll leave the poll open for another 10 seconds. Maybe also some internal colleagues who, of course, do not calibrate. So that might.
Yeah, they don't calibrate their refrigerated thermometer.
All right.
You can do.
Looks good. So let's see how that looks for you. 50% every 6 months, 13% even more than that, and the rest 12 months or less.
All right. Yeah, that's different because traditionally or folkloristic, once a year is quite often, but then really every 6 months is quite popular in LSI industry. So, and if you think, I've visited some plants. For example, I was once in a plant, they had 1,000 thermometers in their process, which have been calibrated once a year using a 10-point calibration because it's written in their SOP. Imagine how much time is spent to do this. So, and that's the reason the customers ask us, oh, dear Andrews and Hauser, what can you do against it to support us? And the first answer we had some years ago has a nice name, iTherm Quick Neck. Let me explain how this should help. So instead of disconnecting all the wires, this quick neck support makes it possible to disconnect the measuring head from the process. So it's meant for on-site calibration. If somebody carries a calibrator to the plant, you can connect it. It can stay connected to the control system, and you place the thermometer direct in your block calibrator. The biggest benefit here is not opening the head, not opening the terminals, means no risk that you do a mistake. Water coming in, the terminals not fixed totally is one of the biggest benefits. The other one is many standard operation procedures say if you open the wires, if you open the connections, you need to do a new calibration of the analog signal path. The input card of your DCS, the output of the transmitter, and so on. So you need to do a simulation or whatever. If it stays connected, you can skip this because the DCS is still online and you always see what is happening. So that means you do this calibration by accident because you put your sensor connected to the DCS, to the 100 degrees calibration bars, and then you immediately see, all right, I see on my DCS screen 100.02, so which is probably inside the tolerance. And because of that, you save a lot of time. The numbers we got from our customers said that the typical time goes down to 10 minutes instead of 30 minutes before. So the time the plant cannot produce is drastically reduced. And additionally, you have no risk of damage of the connection errors and so on. So you save energy and you are in a better situation according to the risks. That is the idea behind this quick neck. How does it look in reality? So we have one of these samples here. This is the quick neck connection. So this part here might be fixed in the plant by the flange or whatever, and then I can, with one hand, dismount it, put this into my calibration bars, and the other way around, it is installed easily in a few seconds. This is the idea behind this quick neck technology, behind this helping to save time and better risk monitoring during the calibration. So we in temperature measurement are often faced with something like, yeah, flow meters are interesting, flow meters are so innovative, we have radar, 80 gigahertz, high tech, military, more or less space technology, and you with your PT100, this is so boring. So there couldn't be something for innovation. And this was also told to this guy, he's Max Planck, a German physicist. When he started to study, his professor told him, oh, please do not study physics. It's so boring. Everything was discovered. There's nothing to do for you. Do something else. He hasn't heard to this. He hasn't believed. So instead, he studied physics. He won the Nobel Prize later, 1918. He discovered many, many interesting things like quantum physics. And so if somebody told us some years ago there's nothing new for temperature measurement, that's also not true, because 2-3 years ago we went to market with a totally brand new technology. We gave it a nice name, iTherm Trustsense. And I maybe have an idea. Ben has a next question for you. So maybe I know the answer already, but I want to be safe.
Definitely. So have you ever heard about the iTherm Trustsense? The only, should we spoiler, self-calibrating thermometer on the world's market?
Maybe.
So once more, a poll, this time also to check. 70 minutes ago we started.
Are you still there?
But it looks all right. So switch off those cat videos on any other platforms. It's time to come back here. Okay, and awesome.
Yeah,
71% already know what we are talking about now. But what is really great?
Switch the camera to them, so they can explain.
Not sure about that. The great thing is, if we let this guy talk about Trustsense freely, then that would easily fill the complete, not only afternoon, but night. So 5 hours, I think, is the record so far.
In one of the companies, in a Swiss company, well known, I had a 5 hours presentation about this.
So world record, not only innovation, but also world record content. But therefore, if you ever heard about it, maybe your altitude is rather high from the product knowledge. So ask all your questions. The expert is here. We gathered some frequently asked questions for the very end of this presentation, but also feel free to shoot at us. I'm sure if I can't answer, I got the right Joku with me. So please go on. And most people know about it, but not to forget, about 30% of you don't. So therefore, welcome to the Trustsense show.
Oh my God. So, all right. So the general idea was to help our customers to reduce the risk and save time and money. And to do this, we took the traceability chain and built the lab into the sensor. And this was done that this is a systematic interview to the Trustsense. We have a PT100, the industry standard for temperature measurement, installed in the sensor tip. Known and usual. But at the back of it, there is a reference. And this reference is using a principle which is named the Curie principle. This material, it's a solid material, is changing its physical properties at a certain temperature, the Curie temperature. It doesn't melt. It is just changing internally. Now, we will have a very common example of a similar thing later on. That means it's not a sensor. It's not that we combine or one sensor and another sensor and look to the average result or whatever. This is not a temperature sensor. It is a phase transition material. It's totally changing its properties at a certain temperature at once, and not as a process like a sensor, which is increasing, for example, the resistance with the temperature. To make you understand this, we prepared a demonstration here, and we hope it works, because we have a lot of things here. So what we have now here is, maybe you know, maybe Ben does not know what this is, but I know he knows what it is. It's a hair straightener, hair styling tool. We use this just only as a source of heat. Now I switch it on, so it's heating up now, and we will see on my screen, hopefully. Maybe I need, yeah, now it comes. We see now the two lines. We have a blue line, which is the temperature broadcasted by the Trustsense. We have a red line, which is a whatever signal of this reference material. It's not relevant that there is a value behind it, because what we will see is the behavior of this signal. You see the temperature is rising up very fast, and the red line is moving a little. But if we just wait a few seconds until we pass the Curie temperature, which is in this case around 117.5 degrees, now the crystal, the material, is giving a signal. It has drastically changed its properties. The values have been multiplied by the factor 3 in 1 second. That means the Curie temperature was passed, and the crystal has reacted. In a way, it's still there, it's still a solid body, but it has different properties now. Maybe you have heard about it, that a similar thing is happening with iron. If you heat up iron above 600 degrees, it's not longer magnetic. The magnetism disappears. And when it becomes colder than 600 degrees, it's magnetic again. And something similar is happening here. Now we have switched off the hairstyling tool, and the temperature drops again. And in a few seconds, we will see the opposite behavior. Let's wait 3, 4, 5 more seconds.
Maybe for all of you who do not know that screen in the background. So we in our setup connected the Trustsense to an RSG45, and that is the web server. And now we have the step response.
Yeah, now we have the step response. You see the signal of the crystal has again dropped by a factor, not just a few percent, by a factor. And now the sensor has noticed, oh, there was a calibration event. And now it has monitored that this Curie material has reacted. And now it's performing an internal calculation. There is a memory in it, and does calculate the moment. So it's going back to time when the Curie material has passed this fixed point. What was the temperature in this moment? Is it still the same as a reference temperature, or has the sensor drifted away? That is a principle of the calibration, and this takes 30 seconds, because this is a 2-wire hard instrument. It's not a 8-core Pentium processor in it, so we save some energy, and it takes 30 seconds, and now it's ready. It's under steady green light, and so the calibration has finished. When we go back to the screen, we see now we have performed the 11th calibration, and the result of the calibration was 0.02 degrees of deviation. To make you understand, the acceptable tolerance of a double class A sensor together with a high class temperature transmitter would be 0.4. So 400 millikelvin instead of 20 millikelvin here. And I can also have a detailed look to the calibration event. Going to the calibration event log, so we see here at 15:52, we had a calibration event. This is a local time. We have 3 minutes later now, and I can go here and I see, all right, at this time we had a calibration. This is the serial number of this sensor. We have the reference temperature, which is 117.78. The measured temperature was 117.80. So we have 0.02 deviation, and the tolerance, which is here stored, is 0.8. So yeah, we call the result okay. Yeah, it's fantastic. So you can download this as an RTF file. We will see later on a graph what else is possible, how to generate a PDF and so on. I can download it to Word, but this would take time, and the information is the same. This calibration is automatically performed every time the temperature drops in that way. And if you remember the application pictures, if you make milk and you shut off the milk heater because you want to clean it, you will pass the calibration point. If you do an autoclave sterilization and you shut off the autoclave, you will have a calibration. So every time, automatically, this calibration is performed during a cooling down process.
Dietmar, before we go on, we have a couple of questions coming in from the audience, and let's just answer them quite quickly. At least this one can be answered quite quickly. No, the Trustsense does not correct itself, and it shouldn't either way. So the calibration itself is just the comparison of a measurement to a fixed reference, or to a reference in any way, in our case, to a fixed reference point. Dietmar, something to add about?
Yeah, absolutely. This is a totally no-go. If we would adjust the Trustsense because of the last calibration result, the next batch of your process would be different than the batch before, because in the background, typically there's a control loop. So we would take the responsibility to change your product. We would be mad to do this. So we give you the information. This is the result of the calibration. In this point, 0.02, so perfect. In another case, if it would be so high, too high, we come to this, we would give you the information, oh, it's high. We would recommend to stop the process, but the responsibility is at the user, not at the manufacturer of the instrument.
Yep.
Absolutely no-go.
So Mark is answered. All right, yeah, the classic one, we need a 3-point calibration. Is there a possibility to do that with the Trustsense? We will see that in the very end.
Yeah.
So we have a
Stay tuned.
1-point calibration. And of course, there's a difference to a 3-point calibration, but we will come to that from a mathematical point of view in the very end. Yeah, also something we might have heard before, PDF is considered secure, but it is not. So not at all. I could change a PDF quite easily. I guess most of you already did that with either an online tool or any editing software. So a PDF is not any way more secure than an RTF file. RTF file can be opened, of course, with any text editing program. But it is also, like Dietmar said, with the process itself. It is up to you as a customer to keep those documents safe. And it would be the completely same thing if you do a manual calibration and you have a checklist by hand. You need to put that into a cupboard which can be closed, because otherwise someone might come and might change it, might make a copy and so on. You know how to falsify any document. So therefore, All the same with those documents. As soon as it is done, it is printed out. It should be kept safe with you. But within the Trustsense, we keep 350, the last 350 calibration certificates, tamper-proof within the electronics. And there is another option, like Dietmar said, where we also have a tamper-proof storage together with a PDF export. And last but not least, yeah, Dietmar, can you say something about the long-term stability of the device? I know the presentation already, so stay tuned. In a couple of seconds, Dietmar will be there.
This is really one of the standard questions. Yeah, your fixed point, how often you need to calibrate the fixed point and how you can calibrate the fixed point. And my answer to this is, yeah, in the same way like you do the calibration maybe now, maybe today. The standard way to perform a calibration for temperature sensors, and yeah, it's written in the standard, is to calibrate it in melting ice. So if you have ice cubes, they will melt at 0 degrees. So how often do you calibrate your ice cubes? If they are still melting at 0 degrees, do you calibrate if the physics have changed? How long will these ice cubes melt at 0 degrees? I can give you the answer. For the next 10 to the power of 15 years, it will be like this. Because this is a physical property of the ice. It will melt at 0 degrees as long as it is water. And so it's a definition. You don't have to change this. You cannot change this unless you put something into the water. And this is the same situation. We have included a fixed point into the sensor tip, back to the PT100. And this will do this Curie transition as long, forever, as long you won't change its its chemical properties. And how can you? You do not know what it is. And so a fixed point does not need to be calibrated because this is the definition of a fixed point, that it cannot change. And like the ice can be melted and frozen again and melted and frozen again, this Curie material will make the transition. So there's something in the crystal is happening. And so there is no need and no possibility to change it. So it is not necessary and not possible to calibrate it. And what the job of the Curie crystal is to do the calibration at the PT100. And PT100 can change, it can drift. We come to this later. And that is the reason that you need to do a calibration at the thermometer. So, and we have tested it, not ourselves. We've given it to an institute. And as far as I remember, they have performed 40,000 calibrations. Yeah, and as a result, we have a certificate about the long-time stability, which you can show to your auditor if you're using this instrument. That is the idea behind it. So the comparison chain is now that the measuring device includes the test equipment, and still this is produced here in our production site where we have a National Standard Calibration Institute. And so the traceability chain is still closed because we do the original measurement of where is the Curie temperature of this individual design, the individual instrument, and then it is fixed forever. This is the story behind this long time stability. The next question is, okay, we create a certification, calibration certificates every time we have the schooling process where we should put all of these documents into it. And we offer a variety of solutions. And so the total one is that you, like we did here, you can connect a number of these Trustsense instruments. they are communicating using the HART protocol with a data manager. This data manager is reading out the calibration information and can transmit it using the internet protocol to a software which is generating a safe database which cannot be manipulated, and additional from this it can generate PDFs which can be stored somewhere on the file server. And so the idea behind this, if you come to your office, if you imagine you would be the quality guy in a milk company, and on the morning the doorbell rings, okay, I'm the auditor of the XXX supermarket, so please show me your certificates, show me your calibration records about your critical control points for the milk heater. Then you go to your laptop, open your file storage and system. Okay, Mrs. Auditor, here we have the last 200 calibrations. We do these calibrations 4 times a day. You want to have a copy of all of it? So this is a real story. We had a diary not far away. He's doing it like this. He goes to this plant, he sees the green light on the Trustsense, and then he knows everything is fine. So so automated storage of the PDFs and a tamper-proof database on this FDM. That's the name for the software. That's the offering. There are certain steps in between, if you like, and you can do it also with a process control system. You can program it on your own or ask somebody to do this. This is a ready solution which is already in the order code and exactly what we are doing here.
And maybe a good time for another question from the audience. Thanks for being so active. That's how that whole online seminar makes fun for us and lives. And we see it now right here. So how can the certificate be downloaded without the data manager or the FDM, so all those different bypasses?
Yeah, it's also possible. This is a HART protocol instrument. And if you have a HART-able engineering tool like Andreessen-Hauser device care or field care, you can connect yourself to the sensor directly and download the certificates using this DTM, device type manager driver, and you can generate PDFs, you can adjust, you can look to all of the data which is inside. This is another possibility to work with this.
So basically how most of you use the HART communication either way to parameterize, to do the changes, etc. All the same. So with system components and I don't know, active barriers, RN221N with the jacks, just get on the device and get your protocols. Thanks, Dietmar.
Another? One of two? No. Okay. So that was a technology. What we do to make this technology step happen. But the general idea behind it was also not coming from us. We have been asked by our customers about, calibration of temperature measurement and the effects and what can you do? Because what is done during a calibration today is you do your calibration at one moment. In the majority today, like written here, every 6 months you do a calibration. So you do it here, you hope everything is fine, and then you pray that nothing is happening in the next 6 months, which is typically true. You do the next calibration, now you are sure, all right, the instrument is still okay, so also in this period of time everything was fine too. But the fun begins here. If you do the next calibration 6 months later, and then you see, oops, we have a deviation. The instrument has changed. It has drifted or whatever away 6 months later. And the first question is, since when? It was okay 6 months ago. It's not good today. When? Normally, you have no idea. How can you find out? Is it since 3 days? Has it happened because it fell down during the transport from the process to the lab? Or has it happened after it was calibrated, it fell down before somebody installed it? Oh, nobody has seen. Nobody knows. So, and what to do now? Is this a problem? It is a problem. Was it a serious problem, or how serious a problem was? Who is to involve? And how serious is it? Do I need a product recall? So was the sterility, the hygienization of the process was not guaranteed? Could there be some bacteria in it? And what do you think would be the financial effect on your company if this has happened? If I think the example we had was after 1 year, but just to have your rough feeling, what do you think is the financial effect on your company?
So, poll is open. You are able to vote and let us know. What do you think? Less than 10,000 euros? Of course, you can translate that to your local currency. US dollar almost 1-to-1. 10,000 to 50,000, 50,000 to 100,000, or more than 100,000 euro. Just give us a rough gut feeling and think about what Dietmar just said. The investigation is one topic. Of course, a possible product recall would mean much, much more, and not to think of what it would bear for you in customers' perception when there is
image of your company.
Yeah, for a food scandal or pharma. Don't think about pharmaceuticals.
No, better not.
No, but show us you're still here. We are in the last couple of minutes, and let's check. We will close the poll now, and we will have a look at the results together, which is 50-50.
No.
Some of you really cheap, and some of you really not so much. So let's close this and go back to the presentation so that Dietmar can show us what we have as a rough numbers in mind.
Yeah, and this might be because the visitors here are spread around the world. So what I can show you is not grown on my ideas. This was a clear feedback of a customer. We have a good customer not far away. We are in close contact, and he told me a story that there was a measuring instrument which was not a thermometer from us, something totally different. And they found out that it was not accurate any longer after the calibration interval in a pharmaceutical company. And he told me it took them 8 weeks of engineers or quality managers to investigate since when it could happen. Have we seen any process changes since when or what? So they looked for half a year of documents. Where is the product now, or where can it be? Is it already in the people, or is it still on stock, or whatever? 8 engineers weeks, and only the labor costs, which is for sure here in Germany different than in other countries, they came to a result of 32,000 euro or dollars because of a bad calibration result of a measuring instrument. And then a lot of guess. If this could happen to thermometers, the number I've heard from another company is that approximately 0.5% of instruments have a problem during a yearly calibration. You can imagine if you have 1,000 thermometers, there will be a similar effect once a year or every second year. And not covered in this calculation is the product recall. So the numbers we had from you might be with or without recall, might be based on different labor costs, might be based on different industries. So the truth is in between what we've seen before, more or less in the middle. The recall is not included in this because we have no idea. This can be really a lot. For example, I had one example. If you have a pharmaceutical company in Germany, you have, and the recall would mean you have to write a letter in paper that's written in the law to every pharmaceutical shop in Germany, which are 50,000. And only the stamps would be a lot more than this, would be 50,000 euro in stamp costs. All right, so you should avoid this. And this is the general idea of this change in calibration concept, what we are talking today. Because the way calibration is done today is like this example. If you are afraid of a thief coming to your house, what can you do to feel safe against it? Calibration like performed today is like that you once a year ask a policeman to come and look if he sees a thief under your bed, in your wardrobe, in your bathroom, and he says, no, it's not there, and then you feel safe for the next 6 months. That's how calibration is performed today. What we offer is a watchdog. He sits in your house, in your process, and it will bark if something strange is happening. And that's our trust dog. In fact, this gives you more safety because the dog is always there. Every time we have a cooling process, the calibration is done. You might do both. You will be obliged to do both because performing a calibration in regular intervals is written somewhere. We come to this. So probably you will do both, but maybe you can call the policeman less often. That is the idea in behind. All right. During my, I don't know, 250, 300 customer presentations, I received a number of questions. Most of them I have heard 295 times. So we have written them down, but you will have the chance to
ask your own questions. And therefore, just briefly, I have one more question in the chat already gathered. So whether this additional thermal mass, so the reference, could create a different response time response in the sensor. And therefore, if you were not there last Tuesday, where we had an online seminar on the sensor technologies in general and what is important about the response time of a sensor, it is always the position of the sensor. So our iTherm QuickSense is so fast because it is soldered right to the tip of the measuring insert. And therefore, the thermal mass itself of the reference has got no influence on the response time, but of course, the Trustsense is not a sensor on tip technology. So just a rough idea. I looked it up because that question came in earlier. So that was the second one you wanted to cover. I couldn't. The response time of a QuickSense is 1.5 seconds in general, according depending on the configuration. 1.5 seconds T90 time, and for StrongSense or for Trustsense, it's 9.5 seconds. So therefore, not slow, but of course not as quick as a quick responding sensor technology. But that's it from that side. And we are already 4 minutes late to what we originally scheduled. So therefore, thank you for being here. If you need to leave, if you do not need to leave right now because the next appointment is waiting, please stay with us the next 11 minutes. So give us the full hour to have a few of those frequently asked questions, especially 1-point versus 3-point calibration, because that is a really high runner question all the time, which will follow in the next 11 minutes from now on. Right?
Yeah.
Okay.
If I hurry up. Yeah. Okay. So yeah. What about GMP rules and FDA? I always hear, oh, I cannot use Trustsense. The FDA is does not allowing to change the process. I have heard this so many times that I really took the time to look into these rules, which hard stuff you can imagine. So I did it for you. So what is written there? What is really the wording? So the FDA rules of process validation, general principles and practicals, a US document published in the year 2011, more than 10 years ago. What they asked for is continuous process validation. Yeah, what we are doing is continuous process calibration. We perform this calibration every time the sterilizer cools down, the milk processor goes down, every time, continuously. It is not, you cannot switch it off. It's always on, continuous process validation. We do this now. They have asked for it 10 years ago. More details, GMP rules, good practice guide, risk-based approach to calibration management. That's what the Thor tools curve we have seen. Chapter a lot, 7799 written here. I have some publications outside where you can have a detailed look. What they ask for 11 years ago, even before the FDA, they mention self-calibrations and online alarms since 11 years. They asked for it. We have it. They said these self-calibrations and continuous validations can be used to make the intervals between the regular calibrations longer. That's exactly what we recommend. There are rules to do it. If you have new values, new results, and they have been good, and imagine you have your regular calibrations and you have 100 automatic calibrations in between, and all have been good. Then it's clearly stated you can double the interval. And if you have 6 months now, after 1 or 2 years, you can go to 2 years, according to the rules. 1-point verifications have been mentioned in this document 11 years ago. What we have is 1-point calibrations, better than asked. So it's not in a way that the FDA or the GMP rules say you cannot use it. It's the opposite. They have been asking for it for a decade, and now it is there. So the question will be, the question of the auditor will be someday, there is a better technology, why you don't use it to reduce the risk? Because every time a cooling means a calibration. So it's the opposite. The GMP would love it. We are not allowed to talk to the FDA directly because we do not manufacture instruments. But if you are a manufacturer, ask them, show them, you will get this answer. I have a lot of publications outside. You can ask your local ENH representative about it. So then you can read it, all the texts. And so we cannot publish you these documents. You have to buy them on your own, but I can give you the literature hints. Where is what and what is our answer to it? So this is the most common question for LSI applications, life science applications. And yes, a typical one, as Ben already stated, yeah, it's 1 point, and my SOP asks for 3 points. Go back, FDA, GMP, 1 point is something you can work with. And for the mathematical background of a PT100 measurement, the temperature is changing the resistance according to a formula, to a physical law in between. And this is looking similar to this for positive temperature. The temperature of the PT100 at a certain, the resistance of a PT100 at a certain temperature can be calculated by the R0. This is a 100 ohm at 0 degrees, 32 degrees 0 degrees Celsius, 32 degrees Fahrenheit melting ice temperature, multiplied with a bracket 1 plus A multiplied with the temperature plus B multiplied with the temperature in square. So what does drift means? As long as a PT100 is still there, it's not short circuit or not totally broken, drift means this formula, the variables of the formula have changed. And because this is a linear equation or a quadratic equation, which is valid for every temperature in a range, it is not possible that only one temperature is affected by any kind of drift. If you have a drift, the complete curve will be different than before. And so this makes a very easy rule. If a thermometer has a deviation at one temperature, doesn't matter which, it cannot be accurate at any other point. This is obviously. And what we do is, if we find out that at the Curie temperature there is a deviation, no matter where this Curie temperature is, at the process temperature it cannot be accurate any longer. So the watchdog is barking, is making an alarm and says, oh, I have found a mistake. Dear user, what should we do? And you can also convert this the other way around. If the calibration is right, and it was right yesterday and the day before and the 100 days before, from the day it was produced in the calibration lab, there was no deviation in this 1-point calibration, it must be good also now. And why that? Because why do PT100s drift? Now, we have made a lot of experiments, and also the literature, if you look, will give you the same answers. Why do drift, and which of these parameters? We can change the basic resistance, the inclination, or which is more or less how, if there is a curve, non-linearity, that's the word. So the main risk for a PT100 is the calibration itself. If you dump your naked measuring insert into your hot calibration bath, it's a thermal shock. The thermal shock is changing the basic value. And this is multiplied to the bracket, so the complete curve will be shifted to a different position. We will see it on the graph later on. The same will happen for mechanical shocks. If your sensor falls down, there might be some mechanical stress on the PT100 itself. It will react in a way, and again, multiply to the bracket, the complete curve will be different. So talking about the main factor here is the A, which is more or less the inclination of the characteristic line curve. And you can change this factor A mainly by high temperatures. Because it is platinum, and platinum as a metal comes in so-called grains, so small crystals, and at high temperatures the grains start to grow, they connect each other, and this can change the material structure and change the factor A. This, according to literature and our results, happens at temperatures higher 400 degrees. Yeah, the Trustsense is limited to 160 degrees, so this is not a temperature which is, it's not exposed to 400 degrees, cannot happen. And the next one, even less, chemical contamination of the platinum sensor itself. And the question is how? How should this be possible? If you imagine, sorry, I was out of the picture, this is a Trustsense with a thermal well. You have a thermal well. So if you want to destroy the PT100 or the Curie material, you have to penetrate a thermowell, stainless steel measuring insert, crawl into the sensor and exchange the platinum by something else during normal operation, during the signal is not changed. How probable is this? I have no idea. I cannot imagine. So it cannot be happen. And also the last one, factor B, might change at temperatures above 200 degrees outside of the scope. So that means the main factor which are a real risk in your application are mechanical shock, thermal shocks. And they can be easily seen because if this would happen, the curve is looking like this. If this would happen, the green curve becomes to the red curve. We do the calibration at the Curie temperature. We will see a difference. This difference is not totally constant, but big and in the entire measuring range. That means if we identify a sensor to be bad at the Curie point, it's bad at the process temperature. And the other way around, if it's good at the Curie temperature and all of the risks affect the entire curve, I personally have no idea how could it be bad at any other temperature if it's good at the Curie temperature. That is the basic principle of the one-point calibration. It is too long to explain it to the auditor, I think. So our recommendation is you won't stop manual calibration, but you can easily extend the intervals according to the rules of the FDA to 2, 3, 4 years or something, and the rest is done automatically. That is a new approach in the calibration we like to offer you today. It took me a while to understand this, and so I have written down it in a white paper booklet, which is available. And if you don't find it, ask your local ENH rep, so we will provide it.
We might also put it in the follow-up mail. So yeah. So as you heard, it took a while for Dietmar to understand it. It took a while for us to get that information through to you. We have a few more questions which now would stretch the time to too much. So we will follow up one by one directly to you. And apart from that, it was a pleasure talking to you, even if it was a rather one-way discussion. But if you liked it, visit us more. There are more online seminars by Andres and Hauser, the tech boosters from Digital Solutions on all those digital communication topics. I can highly recommend, and all those other online seminars you find on www.endres.com are also, of course, highly recommendable, whether it's flow, analysis, level, pressure, whatever there is. Thanks for being here. Stay healthy, stay safe. Dietmar, the last words are yours.
Yeah, thank you very much for attending. You can follow my LinkedIn channel on EH_temperature know-how. Then you will see when we are doing new online seminars, or if I have find something which might be interesting for you. Thank you very much.
Take care.
Bye.